My name is Meisam Amani. I'm a remote sensing team lead at a global consulting and engineering company called WSP. Today I'm going to talk about wetland mapping and change analysis in Canada using advanced AI and remote sensing techniques. Just letting you know that I did my PhD on wetland mapping in Canada, and it's been about 9 years that I'm working on wetland mapping in Canada using AI, cloud computing, and a variety of remote sensing datasets. And today I'm going to show you some of the results of some of our projects, actually, both in industry and also in academia. So here is the agenda. So first, I will give you a brief introduction of wetlands and remote sensing for those people who don't have background in wetlands and remote sensing. Then I will talk about the study area and the data sets, mostly remote sensing, actually data sets that we have used. I'll show you some of the methodology, and finally I will go through some of the our previous results. So wetland services. Wetlands are great natural environments, and they provide a variety of services to both human and the environment. So for example, they control flood, erosion, they purify and clean water, they protect shoreline, they're important for soil and water conservation, and they're great resources for carbon storage. And in Canada, I mean, they're great for recreation and tourist activities. And because of these services, actually, they are called kidneys of environment. So that's why it's very important to monitor these important environments with the most recent technologies. And what is remote sensing? So remote sensing simply is the measurement of object properties from some platforms, like the platform that you see in this picture. So this presentation will mainly focus on some of those ground-based and in situ data, and also which are not actually remote sensing, but they're actually collected by remote sensing systems like GPS measurements. And we will mostly focus on the satellite observation. Just letting you know that each of these remote sensing platforms has its own advantages and limitations. And that's why at the beginning of any project, we should first discuss about the advantage and limitation of each of these platforms and select the most optimum solution. So generally, wetland classification methods can be divided into two groups of traditional, like field survey, and remote sensing methods. So field survey methods are usually expensive. They take lots of time from laborers. It's not practical for large areas because the cost will increase significantly. And it's not practical for wetland change monitoring, especially if we want to monitor and see the changes in the past and we don't have field data, then it's not possible actually to do a change assessment. And finally, there is accessibility issues because wetlands are mostly located in remote areas, and it's difficult to access them through field surveys. But although they have these limitations, but they're important for any remote sensing actually models, because especially when we are using AI models, because we need these in situ data for training our AI models and also validate our final products. On the other hand, we have remote sensing methods, which are generally cost effective. They can provide real-time data sets. Remote sensing data, especially satellite, cover large areas, so we can map large area with, for example, with a single satellite image. They provide repetitive observation. For example, satellite moves around Earth and collect images from any place in the world every, let's say, 6 days or even every day. So they're great resource for change assessment. And finally, there is no limitation in terms of accessibility because we can collect data, for example, from satellite from anywhere in the world. So wetlands in Canada. So each country has its own classification system for wetland. And they're different because different countries have different ecological characteristics, and that's why they have different types of wetlands, and that's why we have different wetland classification system. In Canada, there are two types of wetland classification system. The most important one is called Canadian Wetland Classification System, CWCS, which actually divide wetlands into 5 classes that you see at the bottom of this slide. So they are called bog, fen, marsh, swamp, and shallow water. And some of these wetlands are also available in other countries like shallow water and marsh. Some of them are specific for Canada. And even if their name are the same, but their ecological characteristics are different. For example, bog also is classified in other wetland classification system in other countries, but the characteristics in the of bog in Canada is different, for example, from the bog in, let's say, UK. And it was estimated, this is a old report, but it was estimated in 2012 that 13% of the country is covered by wetland. And this is a large area, a large portion of the country. And the studies have showed that over the past decades, human activities and climate change have posed a serious threat to wetlands in Canada. And that's why it's important to map and monitor wetlands using advanced technologies in Canada. And when we say advanced technology, remote sensing and AI, cutting-edge AI models are also a part of those advanced techniques. And actually, this presentation is going to provide you some information of wetland mapping in Canada using AI models and different remote sensing datasets. So study area is, I wanted to provide several study area, but just letting you know that I have done maybe over 30 different wetland mapping projects and studies. So we have done projects all over Canada, I mean, in different provinces like Newfoundland, Ontario, Alberta, British Columbia, and also we have done projects for the entire Canada. So the study area is the entire Canada. And in terms of the data sets, we are usually using 2 types of data sets, in situ data and remote sensing data. And in situ data are mainly GPS points from the location of the different wetlands. For example, people go to the field, when they see bog, they record the GPS point and they make a note that this is bog. And we also get some, actually can drive some, not in situ data, I mean some reference samples using drone high resolution images. So that's why when we use drone high resolution images, we actually reduce some of those GPS point collection surveys. And in situ data, as I mentioned, they're important because we usually use these in situ data for training our AI models and also use them for validation of our final remote sensing products and for accuracy assessment actually purposes. In terms of the remote sensing data sets, so we have used a variety of optical satellite data, like very high resolution water wheel 2 satellite with half-meter spatial resolution, rapid eye, open access Landsat 8, and Sentinel-2 satellites. We also use radar images like Sentinel-1, RadarSat, ALOS, and TerraSAR X. And we also use DEM data, which are important for wetland mapping. And these DEM data come from both photogrammetric methods and also LiDAR data sets. So methodology, in this slide, you see some of the flowchart of the methods that we have so far developed for both wetland mapping and change assessment. And I'm not going to the detail of these flowcharts. I will just provide a summary of the most optimum methodology for wetland mapping in this next slide. But if you need, I mean, any more details about these methodology, you can look at my Google Scholar profile, which has about over 30 articles on wetland mapping and change assessment over the past 9 years. So if I want to summarize the general methodology and the publicly approved, I can say, methodology, remote sensing method for wetland mapping, I can say that the best result usually comes from a combination of optical, radar, and DEM data. So if you have these 3 data sets, then you will get the highest accuracy. And each of them, because have its own advantages and disadvantages. So when we combine them, we're actually combining the advantage of each of data and we get the highest accuracy. The other important thing is the importance between pixel-based and object-based image analysis. So the literature has showed that the object-based classification method always provide the higher accuracy compared to pixel-based, especially when you have high resolution satellite images. In terms of the AI models, random forest model provides the decent level of accuracy for wetland mapping. But if you have a large amount of in situ data to train deep learning model, then deep learning would be better than random forest. If you don't have a high amount of in situ data, then go with random forest classification algorithm. The other important thing is the difference between single data and multi-temporal remote sensing data sets. Just letting you know that wetlands are dynamic environments. That's why when we use multi-temporal data sets, we get the higher accuracy for wetland mapping. And finally, in terms of overall accuracy, I can say that we can get up to 90% overall accuracy in wetland mapping. And final point is using some cloud computing platforms that are recently getting popular, like platforms like Google Earth Engine for wetland mapping. And I have done, I don't know, maybe over 10 studies utilizing Google Earth Engine for wetland mapping and large amount of remote sensing data sets in Canada. I know that we're a bit behind of the schedule, so I'll try to be fast in showing the results. I'll just provide only three of the result of our three projects. So the first one is actually wetland mapping in Newfoundland. I worked on this project during my PhD, so we picked 5 study area in Newfoundland and Labrador. Each was about 700 square kilometers. Over 3 years of my PhD, I have developed, I don't know, 5 different AI models, I believe, for wetland mapping at these sites, and these are the level of accuracy. So the overall accuracy, as you see, is around between 80 to 90. Producer and user accuracy for classes, I mean, individual classes can be around 70% to up to 80% of accuracy. The next project was about creating the first Canada-wide wetland inventory map. And to do this, I have used Landsat images and also Google Earth Engine to process over 10 terabytes of satellite images to classify wetlands for the entire Canada for the first time. Here you see the percentage of wetland versus non-wetland for different provinces, and also the area of different wetlands based on these first Canada-wide wetland inventory map. So a large portion of most provinces are covered by wetlands in Canada. And my final example is about wetland change assessment in Alberta. So we have done similar study in Alberta, in the province of Alberta, Great Lakes, and also for St. Lawrence River in Canada. And I'm showing the results only for Alberta. So we create like base map, and then we assess the changes over the past 40 years. So from 1980 to 2022, we assess wetland changes. And for example, here is the change versus non-change wetland map. So red area shows changed area and unchanged area are blue. So we have seen that most changed area are located in these oil sand regions where there are lots of oil exploration. And there were also some changes due to cropland activities. My final slide. So this is also some extra results where it shows gain and loss in wetland. So green shows gain, which means that wetland has increased over the past 40 years and has changed, for example, from forest to wetland, and red shows wetland loss, which means that wetlands decreased from 1980 to 2022. And this is mainly because of, for example, some fence has changed to forest area. And this is also transition between different classes. So for example, bear and bog, how they transition from one class to another class in actually 1980 to 2022. So yeah, this was all I wanted to talk about. I know I my main purpose was just providing you a big picture of wetland mapping in Canada. There are lots of details behind each of these models, each of these projects, but let me know if you have any questions at the end of this webinar. And also you can look at my Google Scholar profile if you need more information.